Hi everyone and welcome to the beginning of topic 6. Today we are going to talk about finding the measures of interior and exterior angles of polygons. Now our first piece of information is identifying what is a convex polygon. And our convex polygons are going to be closed figures that have interior angles that are all less than 180 degrees. So all of our vertices are pointing outwards. You're not going to have any inwards motion. So notice some of these examples of a convex where all these would be less than 180 degrees versus having a concave pentagon whose angle here is bigger than 180 degrees. Or another one with hexagons, we have a convex hexagon with all those interior angles being less than 180 versus one that has an interior angle that's bigger than 180, that would be called concave. So in the following examples, are these polygons convex, like the examples above? Would they be considered convex? Yes or no? Now, we want to be able to prove the angle sum for different polygons beyond our triangles. And a reminder, triangles have an interior angle sum of 180 degrees. This is a fact we've been using a lot this entire semester. So if we look down below at different polygons, notice if we start at each of their vertices and draw in diagonals to connect to opposite vertices, we are drawing in a different amount of triangles each time. So for instance, this quadrilateral four-sided figure, so n means number of sides, you can draw in two triangles, which means 180 plus 180, there's a total of 360 degrees. Or if we draw in 1, 2, 3 triangles in a pentagon, a five-sided figure, there would be a total of 540 degrees in that figure. Or there are 1, 2, 3, 4 triangles drawn in this hexagon, six-sided figure. So if we add up 180 4 times, our total degrees would be 720. And then our final example, we have a heptagon, a seven-sided figure. We have 5 triangles we can draw in. And again, if they each measure 180 degrees, we would have a total of 900. So do you notice any patterns between the number of sides in each of these and how they compare to the amount of triangles we can draw? Well, hopefully what you are noticing is the number of triangles for each is 2 less than the number of sides. So what that allows us to do is create an ability to find the total interior sum for any polygon we want. And that formula is we take 180 degrees and we multiply it by the number of sides minus 2. So for instance, in our first example, okay, we have a 1, 2, 3, 4, 5, 6, 7, 8, 9-sided figure. And we want to determine the sum of the interior angles. So we're going to take 180 and multiply that by n minus 2, the number of sides minus 2, because we know that that's the number of triangles we can draw. So 180 times 7 gives us a total of 1,260 degrees. We also want a decagon, so that is a 10-sided figure. So the sum of the interior angles, again, 180 times 10 minus 2. So 180 times 8 would give us a total of 1,440 degrees. So this is going to work for all of our convex polygons. And we can find that total interior angle sum for beyond just a triangle. So we have 2 examples for you to try. We have a 15gon, so a 15-sided figure, as well as this octagon, so an 8-sided figure. What are the interior angle sums? Now we also can work backwards to find how many sides our polygon has given the sum. Because we know, for instance, that if the sum is 3,960 degrees, that has to equal 180 times n minus 2. Now we could distribute and solve for n, but I think an easier way to start solving this problem is to undo this multiplication of 180 by dividing. So we could take 3,960 divided by 180, and that's 22, and that equals our n minus 2. Now, reminder, we want to make sure that we are getting n by itself. So we would add the 2 to both sides, so our number of sides is actually 24. Now, you can always check your answer as well on this, that if you plug back in the number of sides you found, you should get your starting amount. So 180 times 24 minus 2 is that starting sum of 3,960. So we can double check, but that is the correct answer. There's another one for you to try. If your interior angle sum is 3,600, how many sides would your polygon have? Now, our regular polygons are polygons that have sides and angles that are all the same size. So, for instance, we have examples of regular polygons versus polygons that are many of them convex, like this rectangle, for instance, or this triangle, but all of the sides are not the same measure. So regular polygons, again, have all the sides and interior angles the same size, right? They're all equal. So when we have regular polygons, we can find the measure of just one of the angles by taking that sum and dividing it by the number of sides. So think about back when we did equilateral triangles in topic 4. We know that we were finding the value by doing the total sum of 180 divided by 3, and each one would have a 60-degree angle. We now can do that for other regular polygons besides a triangle. So for instance, if we want one interior angle for a 21 gon, we are going to take the total sum, so 180 times n minus 2, and then we are going to divide that by the total number of sides our figure has. So again, we need to start by finding the sum, so 180 times our total number of sides minus 2, and then we are going to divide that by the number of sides to get what each individual wants. So on this one, we're going to have to round. Each one would be 162.9 degrees. So again, that 3420 divided by 21, each is about 162.9 degrees. All right, you try the next one. You want the measure of one interior angle of a regular 15 gon. All right, now we talked about the interior angles. We also want to talk about the exterior angles. Now, what's interesting about these exterior angles is that the sum is always going to measure 360 degrees for all polygons, no matter the number of sides. And then if we want each individual one in a regular, you would take that total sum divided by the number of sides. So in example 4, for instance, we want to find the total sum and what each individual would be for this regular polygon. So this has 1, 2, 3, 4, 5, 6, 7 sides. It's a heptagon. So the sum of the exterior, again, is always 360 degrees. Again, this goes for all of our exterior angles. And then to find each individual one, we would take that total and divide it by our number of sides. So 360 divided by 7, we'd have to round to 51.4 on this one. All right, your turn on this next one. You are going to find the total sum for the exterior angles. And then you are also going to find what each exterior angle would be given this 9-sided polygon. Thanks everyone for watching, and we will work more with these in class.